Nagoya represented Toyota's deepest manufacturing. Conviction. Control every crucial part and leave less to outsiders. That philosophy now faces an unusual sight in Beijing. Beneath a refined Toyota sedan sits core technology. Supplied by BYD, the Chinese competitor challenging it most directly. At first glance, the arrangement appears to expose a former hybrid leader falling behind. A closer reading suggests something more deliberate. Toyota is using proven local hardware to remain competitive in China, while its longer-term battery plans continue elsewhere. Instead of surrendering, the company selected a rival's strongest tool for use inside that rival's home market. The decision raises three questions. What forced an independent automaker to seek help? How strong is BYD's blade battery? And what does Toyota ultimately gain? This analysis follows the market pressure, engineering, and strategy behind the partnership. Subscribing will keep future coverage of the global auto business easy to find. The story begins with the conditions that made this unlikely agreement necessary and why its timing matters so much. China transformed before Toyota's established approach could respond. Tight internal control powered the Toyota production system, while the Prius made the company a defining name in hybrid vehicles. Battery only. Cars received more caution. Toyota favored hybrids and hydrogen, believing consumers were not prepared for a complete electric shift. Chinese buyers moved faster. New energy vehicles, including EVs and plug-in hybrids, passed half of new car sales in the country. Conventional engines and standard hybrids then surrendered share rapidly. Over 12 to 18 months, gasoline and hybrid sales at Toyota and Volkswagen reportedly fell by 15 to 20%. That is a market reversal within one vehicle generation, not a gradual correction. Toyota faced a direct choice: respond quickly or lose relevance in the world's most important car market. The striking point is the company involved. Toyota was not an undisciplined manufacturer. Reacting in panic, its production methods became a global benchmark studied and copied for decades. Yet that famous playbook offered no quick answer to the development pace of Chinese EV brands. Product cycles were accelerating as local companies expanded their electric lineups. Even Toyota's proven methods could not neutralize that speed. The competitive framework itself had changed. Beneath every manufacturer, including Toyota, past success offered no protection here. Battery economics made timing even harder. In an EV, the pack can represent roughly 30 to 40% of manufacturing cost. A poor decision there can erase profit before deliveries begin. Toyota could create an entire battery network internally or purchase proven systems. Starting from zero required billions in investment, dependable lithium, nickel, and cobalt contracts, new factories, trained workers, and years of production. Refinement. Those capabilities could not be established cheaply or immediately. The production learning curve alone would take years, not months. Each quarter spent developing that ecosystem gave Chinese companies more time to release EVs and capture buyers. Toyota could still be negotiating materials, while local rivals delivered vehicles. Capital was available, but time was not. Even enormous gigafactory spending cannot instantly create consistent cell quality, secure resources, or an experienced production team. These stages must stabilize before volume can rise safely. China was updating products in months while a new supply chain required years. That mismatch led Toyota toward a company that had already completed the difficult learning. Purchasing. Mature technology was less about conserving money than avoiding a delay. The market would not forgive now. BYD was a logical choice because batteries came before cars in its history. Founded in 1995 as a mobile phone battery producer, the company moved into automobiles later. Electrochemistry was therefore a core capability before vehicle production began. BYD now manages battery production internally, from individual cells and raw components to completed packs. This vertical integration controls cost and enables quicker changes without waiting for an outside supplier. Few rivals can match that blend of internal scale and rapid iteration at this volume. Its blade battery also follows a different route from the NMC chemistry common in premium EVs. Nickel manganese. Cobalt cells store more energy for their size, but carry higher costs and a risk of thermal runaway. BYD instead selected lithium iron phosphate, or LFP. This chemistry uses cheaper materials, remains more stable under heat, supports thousands of charging cycles, and avoids scarce nickel and cobalt. Pack construction adds another advantage. Conventional layouts place cells into bulky modules with structural material and unused gaps between each group. BYD's cell-to-pack method removes that intermediate stage. Long, thin, blade-shaped cells sit directly inside the main enclosure. This uses the pack's available volume more effectively, reduces unnecessary bulk, and gives the battery its name. BYD says the layout raises volumetric energy density by roughly 50% over traditional LFP packs. The blade battery is claimed to exceed 3,000 charging cycles, equivalent to more than 1.2 million kilometers before meaningful degradation. Avoiding nickel and cobalt also makes production about 20 to 30% cheaper than an NMC pack of equal capacity. For Toyota, that blend of cost, life, and safety is difficult to ignore. It also gave Toyota a mature system already available at meaningful manufacturing scale. The nail penetration demonstration explains the safety appeal. During this severe test, a metal nail passes directly through a charged cell. A conventional NMC unit can rise beyond 500 degrees Celsius almost immediately and ignite violently. Under the same procedure, BYD's blade battery reportedly keeps its surface between 30 and 60 degrees without smoke or an explosion. That behavior matters greatly to a manufacturer whose reputation depends heavily on reliability. A cell that remains controlled after physical puncture reduces a serious fire concern and gives Toyota stronger confidence in placing its badge on the finished vehicle. LFP's lower production expense brings a second benefit. It enables more competitive pricing while China's EV manufacturers continue an aggressive price battle. Safety alone explains part of the attraction, but the combination of thermal stability and lower cost makes the technology strategically useful in production. The cooperation began before the latest headlines indicating planned collaboration rather than a last-minute rescue. Toyota and BYD established BYD Toyota EV Technology Company Limited in 2019 as an equal research and development venture. Their responsibilities complement each other. BYD contributes the electric platform, blade battery, motors, and software integration. Toyota supplies vehicle engineering, suspension, calibration quality, requirements, safety knowledge, and customer confidence. The Toyota BZ3 is the clearest result. Developed for China, the sedan places BYD battery and motor hardware beneath Toyota bodywork and safety engineering. Its opening price is approximately 169,800 yuan, or around $24,000, an aggressive figure for the badge. Buyers can select a 49.9 or 65.3 kilowatt-hour blade pack. Official range runs from 517 to 616 kilometers. Under China's CLTC procedure, fast charging moves the battery from 30 to 80%. in 27 minutes. More important is what the project proves about development speed. Toyota avoided spending years recreating a complete EV foundation. It adopted components already proven on Chinese roads, then applied its own engineering and quality controls. The result reached buyers in far less than a conventional development period. The BZ3 shows Toyota matching China's market tempo without abandoning the standards associated with its name. Proven local hardware shortened the schedule, while Toyota retained control of the finished car. This relationship breaks the traditional separation between allies and rivals. Toyota and BYD pursue many of the same customers, yet jointly develop technology. The arrangement is called co-opetition, where competitors collaborate because isolation has become too expensive. Electric platforms now advance too quickly for every manufacturer to remain inside a strict technical silo. Rejecting a supplier because it is also an opponent is a luxury few automakers can afford. BYD gains much more than sales volume. Toyota's participation supports its credibility as a top-level international technology supplier rather than only a Chinese car maker. Acceptance by a manufacturer known for demanding quality provides global validation that advertising cannot easily purchase. It signals that established automotive groups will build products around BYD hardware. The deal also allows BYD to sell batteries to outside original equipment manufacturers. Spare capacity becomes another revenue stream instead of remaining idle. One company is therefore not rescuing the other. BYD supplies battery knowledge, electric systems, and production scale. Toyota contributes trusted branding, vehicle expertise, and disciplined development. Combining them can move both faster than fighting separate battles in the same market. Depending on BYD today does not mean Toyota has abandoned engineering. Leadership. Critics may view outsourcing as retreat, but pragmatism offers a better explanation. Sacrificing limited independence is a manageable cost if it protects Toyota's position in China's highly competitive market. The BZ3 provides an immediate response while another program continues behind the scenes. Toyota is investing heavily in next-generation solid-state batteries. Commercial introduction is targeted for 2027 to 2028, with ambitions beyond 1,000 kilometers of range. Rapid charging could restore most of that distance in about 10 minutes. Solid-state designs promise faster charging, longer travel, and greater safety than today's best lithium chemistries. Toyota has spent years positioning itself among the leaders of that race. The wider plan has several layers. Proven BYD components address China's present electric wave without requiring years to create a new cell supply chain. This keeps Toyota visible in Chinese showrooms while its own next-generation program matures. Meanwhile, Toyota's global hybrid operation keeps generating cash. Annual volume exceeds 3.4 million hybrids worldwide, producing billions in net cash flow. That business can fund advanced research without exposing the company to excessive financial risk. Those earnings support a technological leap that could restore Toyota's lead when solid-state cells reach mass production. BYD helps Toyota compete now, while hybrid profits build a bridge toward proprietary technology later. The plan separates today's Chinese challenge from the longer engineering objective instead of demanding one answer for both. The company avoids forcing an unfinished battery into today's price war and instead purchases valuable development time for the next stage. Viewed as a whole, the BYD agreement is a practical change in direction, not simply evidence of weakness. It confirms how far BYD has progressed from phone batteries to becoming an international force in energy technology. It also reveals a less familiar Toyota capable of ruthless agility when its commercial position is threatened. That flexibility may rival its manufacturing discipline. The larger lesson reaches beyond these manufacturers. Supply chain. Flexibility is replacing total self-reliance as a major competitive advantage. Companies that insist every important technology must remain, internal risk falling behind. Electrification. Pride can turn long development programs into a serious disadvantage. Manufacturers prepared to source proven systems, cooperate with specialists, and adjust their plans have better odds of staying relevant during the difficult move toward electric mobility. Leadership may belong less to a company that builds every component alone. It may favor a manufacturer smart enough to select the strongest solution for each challenge, even when that technology comes from a major competitor. Market share rewards adaptation, not corporate pride, especially when technology is changing this quickly. If this analysis was useful, subscribing now will bring the next report directly to the channel feed. That episode examines how BYD grew from an obscure battery startup into a technology supplier pursued by major automakers. One question remains. Is this Toyota's smartest strategic move in 10 years, or the first visible weakness in an empire once defined by? In the comments below and explain. Independence? Share an assessment here. Why? The discussion continues in the next report. For Level 2 charging, connect the cable from the wall box to your vehicle's charging port. Insert the connector firmly until you hear a click and see the charging indicator light up. Charging times will vary depending on the battery's charge level, your vehicle's onboard charger, and whether the local AC power is single-phase or tri-phase. In any case, charging your car overnight should give you a full battery by morning. With Level 2 charging, it makes sense to set a charging schedule. You can choose to start charging at a specific time to take advantage of off-peak electricity rates, or to finish in time for your trip next day. You've set a specific charging schedule, but want to start charging immediately. Simply select Charge Now to override the schedule. Monitor the charging progress, either through the vehicle's charging indicator, on the multi-information display, or remotely via the My Toyota app. When the app or vehicle indicates that charging is complete, simply remove and store the cable. Close the charging lid on your BZ4X, and you're ready to hit the road. Of course, you can stop charging anytime. Getting a full charge isn't necessary. It's like charging your phone with repeated top UPS. Public charging includes two options. The first one, Level 2, is available at public AC charging stations. Find them on streets, at public parking lots, or at supermarkets. It is similar to wall-box home charging. And finally, Level 3 of public charging is also known as DC fast charging. It requires direct current, skipping the onboard AC to DC conversion step. With a charging power of up to 150 kilowatts, charging your vehicle to 80% can take around 30 minutes. Use the charging cable provided and simply follow the on-screen instructions. There are many ways to pay, through each station's app or using a credit card. The Toyota Charging Network gives you reliable access to one of Europe's largest public charging networks via a single app. No need to manage multiple cards and subscriptions for Level 3 charging. Open both the AC and DC charging inlets on your vehicle. Insert the charging connector firmly until you hear a click and see the charging indicator light up. You can monitor charging progress on the screen or via the My Toyota app. And that's all there is to charging up, whether at home or on the go.